Hello guys, my name is Enyalide. We are on to lesson 4 and this lesson 4 we want to talk about purely inductive circuit. And in the purely inductive circuit, we are going to be looking at it in a different dimension compared to capacitive circuit. Now, a purely inductive circuit is a circuit that the inductor of an inductance is connected directly to the AC source. It can be the AC source, can be AC generator, it can be AC alternator. That means what the alternator itself. Now, as we are saying, now let's say the current that is coming from the source, let's say is I, and let's take it as the I as I equal to I naught sine omega t. Now, if that is our I that is flowing through the inductor, now as this current flows through the inductor, something will happen. There will be a back EMF, what we call induced EMF. As current flows through the coil, there will be an induced EMF that will be set up in the what? In the inductor. And that induced EMF is what we call the back EMF. According to Faraday's law, it is defined as minus L di over the T, where L is inductance of an inductor. L is what we call what? Inductance of an inductor. While capacitance of the I is the current, and so forth and so on. The T is time. Now, as we say, why does it carry minus sign? Because you see minus sign in the formula. It's because what when the EMF is set up, it moves in what? In such a way so as to oppose the motion that is what? That is produced. That means that according to Lenz's law says that what? That the motion and the current are equal and opposite, which we also call the law of conservation of energy. That means what? That means the EMF will move in what? Will be set up, will be induced as a result of motion opposing the what? The induced current. So that opposition now, the back EMF will now carry what? The minus sign. Now, we are not talking about Faraday's law. I'm just trying to give you the overall the concept involved in the Faraday's law. But let's go because we don't have enough time. Now let's say let's substitute our I there. Now we have what? I equals to EMF is equal to what? Minus L. What is our I? I is I naught. That means substitute this one here. Everything here, substitute it there. So we are going to have what? I naught sine omega t all over what? That means dt. Now, let us differentiate this one now. That's what we want to differentiate because that's what we have there. Now, don't forget that the voltage is also equal to what? The back EMF, which is V minus V. The minus sign is just only showing that it is set up in the opposite direction. That means when current flow in the clockwise, the motion move anti-clockwise. So what we are saying now is this. Listen. So we are going to have it as just turn it, remove the minus sign, make it V. That's what we are saying. Then differentiate this one. Differentiate this one now. What do we have? WT, if you differentiate WT, what do we have? W multiplied by the back. Because this is derivation. Anytime you see a symbol like this symbol means to derive, to differentiate this one. So when you differentiate sign WT, we are going to have W come out there. To come and meet what? We have I at the back, I naught, then L at the back there. Then what do we have again? Now what? It differentiates sign. If you differentiate sign, what you are going to have is cos WT. Please take note of that. Cos WT. Now, having gotten that now, what do you notice now? Look at the current and look at the voltage. The current is sine, the voltage is cos. Now, if you draw the graph, the waveform, that means that the voltage is starting from what? We indicate cos sine graph for current and we indicate cos graph for voltage. This is cos graph of voltage. The sine graph must start from the origin here and we have something like this. Now, what do we notice now? We now notice that what? The current is what? Lagging behind voltage. That is, voltage what? Leads the current by pi over 2. Why is it pi over 2? Don't forget, I told you in the previous lesson 3 that cos Wt is same thing as sine Wt plus pi over 2. That is to say, pi over 2 is the leading what? Angle there. That is to say, pi over 2 is the linear angle. That means current lead voltage and voltage lead current by pi over 2, which is what we have there. Then let us now compare it. So we have V equal to what? Wi naught L. Let's substitute this one here. Sine Wt plus pi over 2. Meaning that V is also equal to V naught, according to our formula given to us in lesson 1, sine Wt plus pi over 2. Now, because there is a leading factor here, it didn't start from the origin. So it started from 90. So there is an addition of what? 90 to that. Now, what will we compare these two now? What do you have? We have V naught equal to omega I naught L. Then how do we make what? Divide both side by what? I naught. So that we can have V over I. So we have V over I, which is equal to XC, no, XL. Why is it XL? Because we are dealing with inductor. So, and what do we call X? X is reactance. What is L? Inductance. So we call it reactance across the inductor. So this is inductor, this is reactance. Reactance across the inductor equal to what? V naught over I naught, as we can see on the board, equal to WL. Now, remember W omega is equal to what? 2 pi F. As we said in the last video. Therefore, we can now say that what? We can rewrite this one as W as what? 2 pi F L as our formula there for this thing. Now, in conclusion, XL equal to V naught over I naught or WL or 2 pi FL or VRMS over IRMS. In case of anything you want us to find, we can find it within this scope. So take note of this formula. If you are writing, just circle that place with your red pen. Very, very important formula. So that is your formula for that. Now, what can we now conclude so far? From the relationship, we know that XL is proportional to frequency. You can see now from the formula. I don't need to talk too much on that. That is, it's what? 2 pi FL. You can see now. Then what will now be the graph? Let's plot the graph of XL against frequency. So the graph of XL against what? Frequency will be a straight line graph. Knowing fully well that XL is proportional to frequency. And if you check from the formula, it's 2 pi FL. So now this is the graph. I'll show you the graph of resistance against frequency, resistance against frequency, reactance across the inductor against frequency, which is what we are seeing. We have shown reactance across the capacitor against frequency. We're going to combine them in our next class. I think this is a basic thing that we need to know. Number one, you must not forget your formula. XL equal to 2 pi FL equal to WL equal to V naught over I naught equal to what? VRMS over IRMS. Don't forget also that you in this purely inductive circuit, the voltage leads the current by what? By pi over 2. In other words, the equation involved by the two of them can be written as what? V is equal to what? V naught sine Wt plus pi over 2 and I equal to what? I naught sine Wt. In some exam, they will tell you to write the instantaneous equation for the what? For an inductive circuit. So these are the two to show. And if you check from the equation, you see that there is a voltage lead the current by pi over 2. Another thing again, you can also say current lag voltage by pi over 2. Current lag voltage by pi over 2. We have also said that what? That in this circuit, the inductive reactance across the inductor is proportional to frequency. And also, don't forget that inductor, I did not mention it earlier, that what inductor store what an energy called what magnetic energy, which is what energy equal to what Li square. That is energy, magnetic energy. Though that one will not be too important in this particular case, but just have it in mind. And again, the power loss, the average power here, don't forget, will now be equal to what? I naught sine Wt V naught cos what? This one is cos. I think from our this thing, we notice that is what? Here is sine, and this one is cos. Can check back and see, because current voltage lead current by 90, so this is it. So we are going to have I naught V naught sine what? Wt cos Wt. So the power we have for average power that, or the instantaneous power, this is instantaneous power that we have for capacitive circuit is still the same thing here. You can look at it very well. You see that what? That our I naught V naught becomes what? Sine 2 Wt over 2. I've given you this formula before. Then don't also forget that the power loss is equal to 0. Power loss is equal to what? Is 0. The power loss in what? In an inductive circuit, purely inductive circuit, is what? Equal to 0. So that is to say, in other words, all the components I've given you, inductor, capacitor, and resistor, the only one that causes power loss is what? Is resistor. Please take note of that. Very important. Very, very important. So far so good. We are able to what? Explain the basic thing about a purely inductive circuit. And I hope you have a nice time with me. Till next time again, when we shall see again. Thank you very much. I remain Engineer Alidi, aka the Shortcut Master. Thank you.